Welcome to What Happened Wednesday, number 2. So on Tuesday we talked about a stability test for state space systems. And we discussed that a system is stable if and only if all eigenvalues of A have a negative real part. So if we have A times V, our eigenvector of A, and set that equal to gamma, which is our eigenvalue of A, times V again, we get this right here, and we can set that equal to 0. And we can rearrange into this form. For this to be true, then the determinant of A minus gamma times our identity matrix has to be equal to 0. So here we have our A, and we just replace the top row for simplified variables. And then we let this term be equal to the determinant of this matrix minus this matrix. And once we do that subtraction, we end up with this term here. Once we get the determinant of that, we end up with this quadratic as shown. Because it's a quadratic, we know that we're going to end up with 2 eigenvalues. Whenever we plug it into a numerical example, we end up with this answer here, negative 1/2 plus or minus this imaginary term. Now, for both the plus and minus case, we end up with a negative real part, or negative 1/2. This means that our spring mass damper system is stable.